Today we're going to try and see if we can get the hang of how this DC motor operates. DC means direct current. So we've got a picture here at the top, which is courtesy of your England textbook. If you've got your England textbook with you at home, I suggest that you read the section. It's page 266 from memory, but it has this picture. It's a very good picture. It's a 3D picture, which shows the whole thing in operation. Now let's just have a look at it. We've got a battery. Okay, so we've got a battery here, and so we've got a current coming out of the positive. This is the positive terminal, and it comes around the corner here, and then it goes into these fellas. This is the commutator. I'll talk in more detail about the commutator. So the current is coming in through this carbon brush. They're called brushes for historical reasons. They used to actually be wire brushes. And then it heads off round towards B, and from B it goes to the back, and then across the back, and then it comes back forwards. The current is coming forwards here to A, and then it comes into it goes round and round a few times, and then it comes out here, and this is the current going round. So the current obeys the current rule as usual, and the current goes like that. Now this current is in a magnetic field, and the magnetic field goes from, as usual, it goes from the north to south pole. So I think I'd like a different color, please, Mr. Colorman. And this is going across this direction. Don't want to make too much mess. Let's draw another one here. But of course it's everywhere in this space. Now you need to get your left-hand motor rule out, and you need to work out why the force on the side labeled B is downwards, and the force on the side labeled A is upwards. So this side has a force downwards, and this side has a force upwards, so it's going to start to spin. So that's the idea. And what should we put in our notes? The current is perpendicular to the magnetic field, and so there is a perpendicular force predicted by the left-hand motor rule. Now, some of you may have noticed that actually not all of the coil is perpendicular. So the two ends don't contribute. It's just the wires going horizontally, so this bit going down here, and then the bit coming back down the other side. So it's from B to the back. The bit going across does nothing, and then it's coming back forwards to the front to A. Now, I mentioned before that the commutator is the trickiest area, and so let's just have a look at that commutator. I've got an extra picture over here, and this picture here, we've got the carbon brushes. They're made out of carbon because carbon is a conductor, but it's also soft. The carbon brushes are held still. The split ring of the commutator, it spins. It spins with the coil. So the idea of this is that we can make electrical contact to the coil which is spinning without the wires getting tangled up. We're going to have current coming in this side and current going out that side, but in the meantime it heads off round the coil. It goes around all the coils before eventually coming back here. So this is a sliding device. Those of you who've got model trains or Scalextrics, the carbon brushes gradually wear away, and that's why it's got these springs on either side to keep pushing them in so they make contact with the split ring commutator. But you might be wondering why the commutator has got a split ring in it. And we will look at that idea next time.